Hi everyone, welcome to Doc Hill's study where I help you get ready for your National 5 biology assessments. In this video we'll be walking through questions from an official SQA paper. The paper and the marking guide are both produced by the Scottish Qualifications Authority, the SQA, and all rights to that material belong to them. I'm using these resources strictly for educational purposes here on this non-commercial channel to support students like you in preparing for your exams. I'll be using the SQA's marking guide to highlight what answers are accepted, but keep in mind it usually only shows some of the correct answers and doesn't explain the reasoning behind them. That's where I come in. For each question, I'll walk you through the thinking process, explain what the question is really asking, and point out some of the common pitfalls to avoid. If anything doesn't make sense to you, or you want to ask about a specific point, feel free to leave a comment. I'll do my best to help you out. If you find this helpful, please give the video a like and subscribe to the channel so you don't miss any future walkthroughs. Let's get started. And this is question 9. Now we get a bit of text here, and it's text about coronavirus, which didn't take them long to put this in the exam. Is it too early? They might have asked themselves, and they decided, no, it's topical, let's go for it. So coronavirus is a pathogen which causes COVID-19. Most people with COVID-19 feel better within a few days or weeks of their first symptoms. Long COVID can be diagnosed when symptoms last longer. All right, symptoms of long COVID include extreme breathlessness, memory, and concentration issues. In some cases, other organs can also be affected, causing other health issues. Study monitored changes in the health of 500 patients with long COVID. Between the start and end of the study, the percentage of patients with extreme breathlessness decreased from 38% to 30%. Those with memory and concentration issues decreased from 48% to 38%. Those with other health issues decreased from 57% to 45%. Oh, okay, that's a lot of numbers there. We might have to come back and just check those out and carefully read them. At the end of the study, 10% had no organs affected, 65% of patients had only one organ affected, and 25% had multiple organs affected. Okay, so up here it says in some cases other organs can also be affected, causing other health issues. Okay, so there we go. Scientific literacy question. They've given you a bit of a dump of text there, a bit of information about this long COVID condition. All right, so the first question doesn't relate to any of that. In fact, I don't think it's in the question. Let's have a look. Okay, so name the type of white blood cell that produces antibodies against coronavirus. Well, there's only one type of white blood cell we learn about in National 5 that produces antibodies, and that is the lymphocyte. So that's just your knowledge of your biology vocabulary, the meanings of all the words, your biology dictionary that you'll have built into your head. If you haven't learned them yet and it's coming up to the exam and you haven't got time to make flashcards or anything to help yourself learn these things, go to my website. It's free. You don't have to sign in. Nothing, no advertising, no nothing. You can use flashcards that I've already made there. They're maybe not completely complete yet. They're a work in progress as always, but go there, use that, gives you a chance. Saves you the time that you would have to spend making flashcards. So you don't have to make them. Go there and use it. The link is in the description below. Okay, that's a free service. You don't have to pay. You don't have to do anything. No signing in. Okay, using information from the passage. There's the passage. Complete the table by adding a column heading and the relevant data. Okay. That's an additional table is required, page 27. Let's have a look at the table. What are they putting in here? Looks like we have to put in data. Percentage of patients at the start of the study, end of the study that had extreme breathlessness, memory and concentration issues, and other health issues. Well, okay, let's see. Those numbers are up here. So extreme breathlessness, let's just make sure we get this right. Extreme breathlessness decreased from 38% to 30% between the start and the end. So 38 is the start, 30 is the end. Now you might want to get out a color highlighter here and have highlight start with one color. I'm just going to circle it, right? So there's the start, and start, just to make sure. Now make sure you don't cover them up so you can't read them. So we've got extreme breathlessness, 38%. We've already got percent up here, so we don't have to put it in here. Decreased from 38% to the end of the study, 30%. We have concentration issues decreased from 48% to Okay, memory and concentration issues, there they are, memory and concentration issues, 48 to 38. And then finally, those with other health issues, 57 to 45. Other health issues, 57 to 45. Okay, now what are these things here? We have to come up with a title for this column. And in fact, you need to watch out for this because you may think that you don't have to put anything in here. It's a column heading. They've asked you for a column heading. This is the only place there is space for a column heading. We need to put one in here. So what are these things? Well, these are all symptoms. And we're going to have to say symptoms of what? Okay, so let's have a look. Symptoms of long COVID. I think I'm just going to take that straight out of the passage and I'm going to put it in here. Symptoms of long COVID. Just a description, no unit required. Symptoms. Okay, now if you just put symptoms in here, you're not going to get the mark because you have to be specific. You've got to say symptoms of long COVID. So that's what's here in this table. All right? Good. Let's see what's in the next page. Turnover. Okay, calculate the simple whole number ratio of the percentage of long COVID patients who had multiple organs affected to those with one organ affected to those with no organs affected. Okay, well let's just move directly up and we're going to get these numbers into position. So I want the original percentage for each of these and then we'll work out what we can do about it. Okay, so let's see. First of all, we want the percentage for multiple organs affected. At the end of the study, 25% had multiple organs affected. Now watch out for that. That's the last one on the list here, but it's the first one over there. So we're going to put up here, we're going to put 25%. All right. Next one is one organ affected. At the end of the study, 10% had no organs affected, 65% had one organ affected. So we're going to put 65%. Okay. And then the last one is 10% had no organs affected. And no organs affected, 10%. Okay. So we have a ratio of 25, 65 to 10. So that's going to be 25 to 65 to 10. Now we have to simplify this down to the lowest whole number ratio. Well, I can't divide those guys by 10. So first thing you check is, can you divide everything by the smallest number? Because if that could divide that, that'll make that a 1. You divide it by itself. But I have to think of something I can divide all of these with and get myself a smaller ratio. So I can divide them all by 5, so that'll make that 2. Right? I can divide 65 by 5. Let's just get the calculator out. 65 divided by 5. Don't make mistakes. No reason to make mistakes when you can carry a calculator. 13, that looks like we can't make that any lower. And 25, 5. So 13 is a prime number. I can't make that any lower. There's no multiples of 13, so it's going to be 5, 13, and 2. Okay, first thing you should always check, can you divide them all by the smallest number? That gets you a 1 here, you can't go any further. If you can't do that, go for the largest common factor that you can think of, that they all have. This one was obviously going to be 5. Couldn't divide by 10 by any of those. So there you go. Those are tricky little questions sometimes, and sometimes you just have to see it. There probably is some funky way of doing it with maths, but that's the way I do it. I'll just keep dividing. If I got something here, I've got 12 there and a 6 there, I would just divide again until I get down to something that I can't divide anymore. I can't divide all 3 of them by the same thing. So we get to there, and that's going to be the answer. All right? Okay. It says here, suggest a reason why the study could be considered invalid. Now here's this word again, invalid. Right? Now validity in biology means that all of the factors in the experiment are controlled except for the thing that you're testing. Okay? So why would we call this study invalid? Is there a reason to say why? Basically, we're asking, is this study properly controlled? Is everything controlled except the thing that we're testing? Okay, so what are we testing? Let's have a look. We're testing the appearance of all of these symptoms in the patients, 500 patients with long COVID. Okay. And these are just patients. This is not done in a laboratory. This is not done on animals carefully given the same diet and all the rest of it. So basically you're saying here is that we could say all of these patients could be different ages. That would affect it. All of these patients could be different ethnicity. That would affect it. All of these patients could be different gender. We're not told if any of these things are true or what we've controlled. If they said a study monitored the changes in health of 500 patients of the same age, of the same ethnicity, of the same gender, we might be able to eliminate all those, but basically it looks like it's just 500 random patients. So we could consider this study to be invalid because all the patients are not in any way controlled to be equal. And so basically with any human being, anybody in the environment, there's just too many variables to control. What you mustn't do here is you mustn't mix this up with reliability. So if you were thinking about reliability, you might say, well, I need to do this experiment on more patients. I need to do more tests. That would be a reliability test. So I need to do 5,000 patients instead of 500 patients. That's reliability, not validity. So you must stick to the variables that are involved and making sure we're controlling them all so that only one thing is being changed. So these patients are all different. There's no clear indication here that the patients are selected for having a particular set of variables. So we could say and get the mark that there are too many variables. Control, okay. Or you could say, take one of those variables and say something like let's say patients may have been different. And then you could just finish that off with ages, gender, ethnicity. You might get away with saying race if you can't think of anything else to say, but ethnicity is the correct term in biology. Underlying health issues, previous underlying health issues. Etc. It must be some kind of variable that you would have to control for. So to do the experiment in a valid way, you would have to have all of these things controlled so that they're the same in all the patients you're testing. And there's no indication that the study did this, and that's going to be your answer. You can just write this, or you could write one of these. Those would be fine. What you cannot write is do more tests, because that's a reliability answer, not a validity answer. And it's really important you get that clear in your head. Thanks for watching this walkthrough from Doc Hill Study. I hope it helped you feel more confident about tackling these kinds of questions. Remember, the answers I've used are based on the SQA marking guide, but it's always important to understand the reasoning behind them, not just memorize the words. That's why I focus on the process, not just the final answer. If you've got any questions, or if something didn't quite click, drop a comment below and I'll get back to you. If you found this helpful, give it a like, and don't forget to subscribe so you'll be notified when the next walkthrough goes up. Good luck with your revision, and I'll see you in the next one.